Assalamualaikum and hi everyone. We are from Group 3, Section 2. We present about the Group Project Hydraulic. Before that, I am introduce myself. My name is Muhammad Azhar Shah bin Azmin, CF220176. With my partner of group member is Rashri Azrin bin Muhammad Syukur, CF220237. Muhammad Ali Fakir bin Syahrul Zaman, CF220186. Muhammad Aziz Fikri bin Muhammad Shidi, CF220193. And Zu Iskandar bin Zukiman, CF220114. Firstly, we go to the introduction. At this year, we have many problem of floodings. There's the post as restrict and cause many people their homes and positions. Late in the year, when the monsoon rains were at the strongest, that's a conference and most comments. It was crucial have a thorough conversion of the water volume and research pattern. Like nearby drain at Taman University Paraja, there's several drainage system problems that by pulling the access and undertaking in-depth analysis, the city was able to take the preventive steps against floods and damage and eroding with the reliable drainage system to keep people and property safe in variable location.
Hello, Assalamualaikum dan salam sejahtera. Nama saya Izrael Syuris Azril bin Muhammad Syukur and my matrix number is CF220237. Saya akan menerangkan tentang literature review for our project. Okay, for literature review for our project is the first one is to find runoff coefficient mixed development C. As you can see using this formula, where C average is a average runoff coefficient, CJ is a runoff coefficient of segment I, AJ is a area of segment I, and M total of segment. And second one is calculate friction slope S using this formula where L is a length of channel, S equal to highest value elevation tolak dengan lowest value elevation divided by L. Okay, seterusnya adalah to calculate the weighted parameter P, seperti yang Dr. ajar sebelum ni, menggunakan formula weight parameter seperti dalam table yang dibentangkan ini, iaitu ada rectangular, triangular, trapezoidal and a circle. And seterusnya adalah identify hydraulic radius R, iaitu formulanya rad R equal to A divided by P, where A is area, P is weight parameter, and seterusnya adalah calculate drain flow TD, as you can see using this formula, where N is main roughness coefficient, R is hydraulic radius, S is a friction slope, L is a length of ridge, and TD is a travel time in the drain in minutes. Okay, seterusnya adalah find rainfall intensity, iaitu I. I is average rainfall intensity, T is average recurrence interval, iaitu RE dengan 0.5 kecil daripada T, and T ni kena antara 0.5 hingga 12 month, and satu lagi T antara 2 hingga 100 tahun. D is storm duration hours, iaitu D di antara 0.0833 hingga 72, and lambda K, theta and N is a fitting constant dependent on the rain gauge location using this formula, as you can see. And seterusnya adalah calculate Q rational using the formula Q equal to CIA divided by 360, where Q is peak flow, C is runoff coefficient, I is average rainfall intensity, and A is drainage area. And the last one is to find to calculate Q capacity. Q capacity using the formula as you can see, where A is area of drain, R is area of per perimeter, S is slope, and N is roughness. Okay, that's all for literature review. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Iskandar bin Zikiman. My numeric CF220214. Now I want to explain about the methodology. In methodology, for flowchart, first I select the ARI and then descriptive sub-catchment. Divide the sub-catchment into a segment of homogeneous land use of surface slope. And then next, estimate time of the concentration I. So estimate the overland flow time, estimate the flow time for all other flow component within the sub catchment, such as a gutters, pipe, and channel, and another things. And next, determine average rainfall intensity of I. Calculate I for design ARI and duration equal to the time of the concentration from IDF data for area of interest. Estimate next, estimate runoff coefficients. Estimate the C values for each segment if they are different land use. And then calculate the average runoff coefficient. Use equation at 2.4. And then the last, calculate the peak flow rate Q for the sub catchment. Calculate the peak flow rate from equation 23. Alright, next, in the investigation, the peak flow for predicting fluid levels using the rational technique was calculated following a specific process. According to figure 3.2, the first step in this process involved selecting the average recurrence interval ARI. For this study, the ARI value was determined to between 10 and 50 years as indicated in a figure 2.1, especially for semi-urban location. The chosen ARI play a crucial role in the calculation of peak flow for the study. Okay, for the formula is Q equal to C times I and A divided by 360. For C is the runoff coefficient C, and C equal to 0.90. Right, next is time of concentration. To get a rain intensity, the time of concentration needed to be calculated. Based on the table 3.1, table pest type is draining flow was chosen to calculate the time intensity because the drainage has been already built in this area. The formula for this time of concentration is T equal to N times L divided by 6 R 2/3 S 1/2. So the formula for friction slope, S is a higher value elevation minus lowest value elevation divided by the length of channel L. So the answer is 0.0041.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Alif Hakim bin Syarul Zaman. Nama metrik ACF 220186. So saya akan membentangkan tentang data analisis. So first kita kena tahu dulu saiz longkang itu, drainage dia. Sebaran bagi drainage ni adalah 2.5 meter dan kedalaman dia adalah 1.5 meter. Okey, 0.5 itu adalah kelebaran daripada bawah dan di atas adalah 3.5 meter. So first kita kena kira area dia. So bagi formula area adalah BY tambah ZY kuasa 2. So masukkan dia dalam formula. So 2.5 darab 1.5 tambah 0.33 darab dengan 1.5 kuasa 2. Kita dapat so total area dia adalah 4.5 meter square. So, kita kena cari perimeter, weighted perimeter. So P. So formula bagi P untuk trapezoid adalah 2Y punca kuasa 1 tambah Z kuasa 2. So kita bila masukkan formula, kita masukkan balik angka tu, kita akan dapat 5.66. So and then kita kena kira R. So formula bagi dengan 5.66, so kita akan dapat 0.795. Untuk cari TD, so formula TD iaitu NL per 60R tu kuasa 2 per 3 S1 per 2. So bila kita dah masukkan formula, so kita akan dapat 6.69 minit ataupun sama dengan 0.112 jam. Determine untuk design dia, flow design drain dia. So kita akan dapat jangka masa dia adalah 50 tahun ARI. Di sini kita mendapati I itu adalah 635.76 mm per jam dia buat. So Q, formula bagi Q adalah of coefficient. I adalah average rainfall intensity darab dengan A, drainage area, bahagi dengan 360 sebab kita nak dapatkan berapa dia punya meter cube meter square meter cube per second. Sebabkan Q peak adalah 19.71 meter cube per second. Kita punya second sizing drainage kita dengan wide dia adalah 4 meter dan kedalaman ni adalah 3.5 meter. So dari situ kita masukkan kepada dalam formula area balik. So area, formula area macam tadi, so kita mendapat 16.622 meter square area dia. So P dia kami dapat 11.158 meter. So R dia adalah R equal to A per P. So yang mana area bahagi dengan weighted perimeter. So kami dapat 1.49 meter. So berapa design Q design dia, discharge design. So bagi formula Q design is equal to A times 1 per M times R 2 per 3 darab S 1 per 2. So kita kami dapat 28.81 meter cubic per second. Data analisis. So daripada situ kami mendapati the primary goal of designing the channel is to ensure that no floods occur in the area. So to achieve this, the new channel section needs to be able to handle a discharge design value that is higher than the peak discharge value. The design the channel section involves making change into its height Y, top width T and bottom width is B while following a trapezoid shape. Assume that the discharge value for the design is 28.81 cubic meter per second. So we assume Q is more than Q peak. So discharge for many equation is 28.81 meter cube per second and discharge for rational method is 19.71 meter cube per second. Is that Q discharge meanings is more than Q so thank you, thanks, that's all for me.
Assalamualaikum warahmatullahi wabarakatuh. Today I'll be discussing about our gains during the hydraulic project. So based on the site that we have investigated, we identified that the main causes of flash floods in the area are caused by surface pollutants and vegetation, as indicated by provided data previously. So we propose a larger drain with a bigger dimension, which is 4.5 meters top width, 4 meters base width, and a 3.5 meter height. This is to combat the flash floods. Also, this because the larger dimensions of the drain water offer advantages in handling a higher in volume of stormwater runoff and improved flow velocity. Secondly, the estimated discharge capacity of the proposed larger drain is improved to 28.81 meter per second, which is a 46% increase compared to the existing drain. Also, adding a floating debris trap acts as a barrier to capture and retain floating debris, especially vegetation which is present during our site investigation. This also will prevent blockages and maintain the flow capacity of the drainage system. As a conclusion, we have learned that flash floods are caused by surface pollutants, vegetations, and among others, debris accumulation. It is crucial that we take a comprehensive approach. We have analyzed the data and considered the factors involved. So we recommended to implement a larger drain design and incorporate a floating debris trap. The larger drain design with increased dimensions improves the drain capacity to handle stormwater runoff and enhances the flow velocity. This reduces the risk of overflow and surface flooding. The estimated discharge capacity shows a significant improvement compared to the existing drain. Additionally, the floating debris trap acts as a barrier, capturing and retaining debris to ensure the smooth flow of water, and also it prevents blockages in the drainage system. By combining these measures, the risk of flash floods can be effectively mitigated, protecting the local communities and several other infrastructures that are present near to the site. It is important that we follow relevant guidelines and regulations which we have followed according to MASMA 2. This comprehensive approach promotes an effective stormwater management and also helps safeguard against the detrimental effects of flash floods.